Hello students! Till now, we have seen two methods of finding roots of quadratic equation. One is factorization method and the other is completing square method. But isn't it easy if we get some direct formula to find the roots of quadratic equation, wherein we can just put the given values and calculate it to get the roots of equation? So today, let us derive one such formula with the help of which we can find roots of quadratic equation directly. The formula is minus b plus or minus under root b square minus 4ac whole divided by 2a, where x is variable of given quadratic equation ax square plus bx plus c equal to 0. A is coefficient of leading term ax square and b is a coefficient of middle term bx and c is the constant term. Note that plus minus symbol indicates that quadratic equation has two distinct solutions. Written separately as first root x1 denoted as alpha equal to minus b plus under root b square minus 4ac upon 2a, and the second root x2 denoted as beta equal to minus b minus under root b square minus 4ac upon 2a. Now students, we have seen the formula used to find out roots of quadratic equation, and this is why it is called as quadratic formula. So let us derive this formula. We will derive quadratic formula by applying completing square method. I've already explained you completing square method in our previous video, so you can refer it in case if you have forgotten it. So to derive the quadratic formula, consider standard quadratic equation ax square plus bx plus c equal to 0. Recall that first condition of completing square method was that coefficient of x square should be either a square number or 1. Now in our equation, we consider a not as a square number. So we divide quadratic equation by a to make coefficient of x square as 1. Suppose we know coefficient is 2, 3, 5, then we can make it a perfect square number by multiplying it with a suitable number. But here, since we don't know what is a, we divide it to make it as 1. And after dividing the quadratic equation by a, we get a new equation x square plus b by ax plus c by a equal to 0. Now students, transpose c by a to the other side of the equation and we get x square plus b by ax equal to minus c by a. We have changed the sign of c by a from plus to minus since we have changed the side. Now according to completing square method, to convert our expression into a perfect square expression, consider the middle term b by ax and take only the coefficient part, that is b by a. Make it half, we get b by 2a. Now make it a perfect square term, which is b by 2a whole square. Add this on both sides of our equation to make it of a form a square plus 2ab plus b square equal to 0. After adding the square term b by 2a whole square to the equation, we get x square plus b by ax plus b by 2a whole square equal to minus c by a plus b by 2a whole square. Now compare this equation with the standard expression a square plus 2ab plus b square. As per identity, we can write down a square plus 2ab plus b square as a plus b whole square. Similarly, our expression can also be written as x plus b upon 2a whole square equal to b square upon 4a square minus c by a. Take LCM for RHS and rearrange it to get x plus b by 2a whole square equal to b square minus 4ac upon 4a square. Take square root on both the sides. We get x plus b by 2a equal to under root b square minus 4ac upon under root 4a square plus or minus under root b square minus 4ac upon 2a. Now isolate x on one side to get the formula x equal to minus b by 2a plus or minus under root b square minus 4ac upon 2a. Now observe here that denominator is same for both the terms. So we need not take LCM and can be written as x equal to minus b plus or minus under root b square minus 4ac upon 2a. This is what is our quadratic formula. Now we can write this individually with plus and minus. x1 denoted as alpha equal to minus b plus under root b square minus 4ac upon 2a. And x2 denoted as beta equal to minus b minus under root b square minus 4ac upon 2a. Now students, when we will substitute the suitable values in this given formula for any quadratic equation and solve this, we will get two values of x. And these values are solutions or roots of quadratic equation. So what we have learned is how we can find roots alpha and beta for any given quadratic equation directly by using this quadratic formula. As you can see here, alpha and beta are roots, that is, values of x at which equation becomes 0. So in general, we can write this formula as x is equal to minus b plus or minus under root b square minus 4ac upon 2a, where x is the variable of given quadratic equation. And students, in the next video, we will see how to use this formula in some examples.